Now we will study the VI characteristics of PN junction diode. In the last class, already we have discussed how a PN junction diode is formed and what do you mean by a forward biasing and reverse biasing. So, this is the symbol of your PN junction diode. Forward biasing means when the P terminal is connected to the positive terminal of the external battery and N is connected to the negative, then this is called the forward biasing. During your forward biasing, P terminal means here the majority charge carriers are holes and the majority charge carriers are electrons in N side. So the majority electrons will diffuse to the P side, whereas the holes from the P side will diffuse into your N sides, so that a junction or an electric field will be set up across the junction. So in the other form, if we draw, this is your P and this is your N. So, due to the diffusion process, a drift current will be developed and a potential will also applied. That potential is called the potential barrier. Now, in this case, the depletion layer will be reduced. Why? Because in your forward biasing, the applied voltage, suppose V is the applied voltage and VB is the barrier potential. Now applied voltage is in the opposite direction of the barrier potential, or you can say the applied voltage opposes the barrier potential, so that the depletion layer, this layer, will thin and the barrier potential will also reduced. So as a result of this, we can say the resistance becomes low. Clear? Similarly, during your reverse biasing, what will happen? Reverse biasing means when the P terminal is connected to the negative and N is connected to the positive. Then the holes from the P side will drift into your N side and the N electrons, means majority charge carriers from N side, will diffuse into a P side. But P is connected with your negative terminal. That means we can say in this case the applied potential and the barrier potential will in the same direction, as a result of which the depletion layer becomes thick, and the barrier potential will also increase, and the resistance becomes high. So in other words, you can say during forward biasing of a PN junction diode, the resistance is very low. That means current will conduct. Whereas in a reverse case or in reverse biased, it offers high resistance. High resistance means no current will flow. Now we will study the VI characteristics of PN junction diode in forward biasing and in reverse biasing. So first we draw the experimental arrangement. This is our PN junction diode. This is connected with a voltmeter. Which is also connected with a rheostat. This is P and N. So P is connected to your positive and N is connected to your negative. And a milliammeter, MA, milliammeter is connected to the PN junction diode, and the P terminal is connected to positive and N is connected to the negative. So this is the experimental arrangement in your forward biasing. Now during your reverse biasing, same, this is connected to your voltmeter and this is connected to your rheostat. This is your battery or EMF, but in reverse case P will be connected to your negative. That means you have to interchange the terminals. This is negative and this is positive. Here microammeter is connected during your reverse biasing. So the difference is for your experimental study or for the experimental observation or to study the VI characteristics of PN junction diode in forward and reverse biasing. A milliammeter is connected during your forward biasing and a microammeter is connected in reverse biasing. Now, if we study the VI characteristics curve or by taking the readings of your voltmeter for the different readings of the milliammeter, that means for the current readings, then the graph will be like this. I means your in your milliammeter. The graph will be that means first the current will increase very slowly till the the voltage attains a particular value or a constant value. That voltage is called as your saturation voltage, or that voltage is called as your knee voltage. This is in a forward bias. And in reverse biasing, what will happen? Means current will be in a microampere. Then the graph will be like this. That means the reverse voltage will increase in according to the saturation or the reverse current, and after that, or when it reaches the maximum value of the voltage, then the current will suddenly increase, and that particular voltage is called as your breakdown voltage. So this is the VI characteristics of a PN junction diode during forward bias and in reverse.